So last time we just went through a whole bunch of laws and rules of exponents. And we use those rules and laws to simplify exponential expressions. So we dealt with that primarily last class. So today we're going to be talking about polynomials, and we're going to be dealing with all specifically only with polynomials. So the word poly, right? The word poly means more than one. That prefix means more than one. And nomials are, like, in other words, a fancy word for saying terms. So polynomials are terms that there's more than one of those terms. So what are polynomials? What is a polynomial? Emil?
An algebraic expression that consists of more than one term.
Wow, that's very nice. I like that. So an algebraic expression that consists of more than one term. I like that. That's very nice. However, it's not complete. So you're right. It is an algebraic expression that consists of more than one term. But what are those terms? What are each of those terms? These terms are actually
Numbers and variables and stuff.
right. They're actually exponential. You can think of them as exponential expressions. And when we say exponential expressions, it's an example of this. It's like saying like this, 3x squared, right? The thing is, we have a whole bunch of them now. We have a whole bunch of them together. And there's a few things that I need to highlight, though. There's a few things. So that one term, there are more than one term that contains the following. I should say, not that contains, that must contain the following. So the first thing is that the coefficients are real numbers. But probably more important than that is that the exponents are all non-negative numbers. I should say non-negative integers. This is extremely important. The exponents for a polynomial must all be non-negative integers. Now, what does that mean? What are the integers that are non-negative? So the word non-negative obviously means not negative. So what are the integers that are not negative? One, two, three, four. That's right. 1, 2, 3, 4, dot, dot, dot. But you're missing one. You're missing a very special integer.
Positive infinity?
Say that again.
Positive infinity?
Well, positive infinity, that's an interesting one, because positive infinity is not, you can't say, hey, look guys, I have infinity. Here it is. So infinity is more like a concept that there is no end. So that's what I mean by the dot, dot, dot. I just keep on going. forever and ever. But I'm not referring to infinity. There's one more you guys are missing, and everyone says it in the chat. 0. 0 is a non-negative integer, and it's not positive either. 0 is in between. It's in between positive and negative. So when I say non-negative integers are the exponents, I say that the exponents for those variables must be 0, 1, 2, 3, so on and so forth. If they're non-negative integers, what does that mean? Exponents cannot be what? Because of that, exponents, so note, from here, what do I say? I say that note, exponents in polynomials cannot be, it can't be what? Negative? And what can't it also be? So it can't be negative and it can't be what? If you're an integer, then what are you not? You are not a nobody?
Spitballing is it integer? I mean, is it what is it called? A fraction? No,
Right,
no number.
right. You can't be a fraction. You can't be a fraction. Like, for example, 5/4. You can't be that. If you're a polynomial, you can't have that. You can't have a negative exponent. You can't have a fractional exponent, and you can't have an irrational. If you do, it's not a polynomial. So I'll give you an example of a polynomial, and I'll give you an example of something that's not a polynomial. So a polynomial, right? So example of a polynomial. P of x is what? 3x squared plus 5x plus 2. That's a polynomial. Why is it a polynomial? Because we have multiple terms. The coefficients are all real numbers. That's like the easy one. But look at the exponents. 2, 1. And what about that 2 here? You can think of this 2 having an x to the 0th power. But what is x to the 0th power? Remember?
1.
1. And what do we know about the exponent? It's 0, which is what? A non-negative integer. So this what? Check. This checks off. Polynomial is a poly. Now, what's an example of something that's not a polynomial? Sometimes it helps to understand what something is by understanding what it isn't. So this is a non-example of a polynomial. So my function looks like this. 10x squared plus 5x to the negative 2 plus 3x to the 1/4 plus yeah, that's good enough. So the moment you see this, what happens? Not a poly. Why not? What's the first flagrant violation?
Negative exponent.
Negative exponent. Boom. Negative exponent. That can't be it. We don't like negative exponents for polynomials. That can't be. And what else can it not be?
There's a fraction in one of the exponents.
Exactly. There's a fractional exponent and there's a negative exponent. So what do we say? Not a polynomial. Does that make sense? So if you understand that, then it's clear as to what is a polynomial, what constitutes a polynomial, and what doesn't. Okay, so now we have a better understanding of what is a polynomial, and what it isn't. Now, what's cool about polynomials is that we can do what? We can add them. So we can apply operations operations on polynomials. So first, let's talk about addition. So again, this might be something you've seen before. So we have 4x squared, for example, polynomial, 3x minus 5. And we're going to add this to another polynomial, x squared minus 7x plus 10. And we want to know, what does this equal when we add these two polynomials? So you may have heard the expression combine like terms. So when we add, we combine like terms. That's it. Quote unquote, like terms. So one way to do that is to just arrange them. Arrange all of the terms of the same kind. So all the terms that have x squareds in them, put them together. All the ones that have x's in them, put them together. And all the ones that are constant, just regular numbers, put those together. And then we combine. So we get 5x squared. We get minus 4x. And we finally get plus 5. And that's the sum. That's my sum. People refer to this as the on WebAssign, they call this the horizontal format. So when you see this, don't get alarmed. It just means that the polynomials are horizontally placed. They're next to one another. Because there's also another way to consider addition using the what's called the vertical format. And I'll give you an example of that. So if I have, I'll get the same example, right? 4x squared plus 3x minus 5. Some people like putting them vertically. The reason why they put this vertically is because you start to notice, so this is like the vertical format. What do you notice? They're lined up according to their term. So 4x squared, again, it's the same idea. We're just combining like terms. It's 5x squared. Then what do we have here? 3x and minus 7x is minus 4x. And then minus 5 plus 10 is plus 5. So you see we get the same answer, but we did it in a slightly different manner. One of them was horizontally, one of them is vertically. On the homework, it says, I think they specify which format to use, but at the end of the day, it's the same. So you don't have to feel confined to do one or the other. It's not really a big difference. It's just visually different. One of them is placed horizontally, the other one is placed from a vertical perspective. But adding polynomials is quite the most simplest operation here. We just combine the terms that are the same, and you've been doing this before. So that's addition. Now the next thing is subtraction, right? We can subtract polynomials as well. Now this one, I just need to emphasize one thing in particular. So when we have x squared, for example, minus 2x plus 7, and I want to subtract this from 3x squared minus 4x plus 7, right? I have to do one thing, and a lot of people gloss over this one thing. What you always have to do, always, so this is always remember. What do I want you to always remember? Can't even spell remember. I have to remember how to spell remember. One thing I always want you to remember is that there's a negative, really there's a negative 1 in front of the second polynomial. This is like my second polynomial, right? And this is the first one. So for the second polynomial, you always remember that this negative 1, in a way, is being distributed to every term for the second polynomial. So then what is that gonna, what's gonna happen after this? So distribute then combine like terms. Exactly. Always remember to distribute -1 to each and every term in the second polynomial. So what you're going to get is the following. You can get x squared minus 2x plus 7 minus 3x squared plus 4x minus 7. Do you see that? And now this becomes like addition. You combine like terms. So I'm going to combine the x squared minus the 3x squared. Then I'm going to combine all the negative 2x plus 4x. Then I'm going to combine the positive 7 with the minus 7. Remember, subtraction is really adding the opposite. Subtraction is really addition. When you say, for example, 5 minus 3, you can always rewrite that as 5 plus -3. That's why the pluses come up. So then when you combine this, what do you get? X squared minus 3x squared is -2x squared. -2x plus 4x is a
2x.
positive 2x. And then 7 minus 7 is 0. So then the result, the difference is -2x squared plus 2x. Boom. Done. Okay? Does that make sense? Make sure that -1 is being distributed to every term in the second polynomial. If you have any questions about that, please don't hesitate to ask me. Okay, so if I have 4a squared minus 7a minus -6a squared plus 5a minus 7, what am I supposed to do for this? What do I always have to do? What's the first thing I do, guys? Distribute the -1. Thank you. Yes. You distribute the -1. And then what do you get? You get 4a squared minus 7a plus 6a squared minus 5a plus 7. So I distribute that negative only to the second term, second polynomial. And then I combine like terms. So I get 4a squared plus 6a squared. I treat that as a thing. Then I do -7a minus 5a, treat them as one group. And then I just have the plus 7 hanging out. So then I get 4a squared equals 6a squared, which is a total of 10a squared. I get -7a minus 5a is -12a, plus a -12a is just -12a, and then plus 7. And voila. That is the difference. Right? So far, so good. Adding, subtracting polynomials should be pretty straightforward. Okay, so now we're gonna have a bit more more advanced or complex operation, and it's multiplication. So when we multiply, what happens when we multiply? So I'm gonna have a certain different scenarios or different cases. So the first case, case 1, is when you multiply a polynomial by a monomial. Okay, so what does the word monomial mean? Well, mono, remember the word, the prefix mono means one. So monomial is one term. So when we have a polynomial multiplied by a monomial or vice versa, so if I got negative 5y squared multiplied by 3y minus y squared, so this is the monomial here. And I'm multiplying it to this expression, 3y minus y squared. Obviously, what am I going to do? Whenever we have parentheses, I distribute. So when I distribute, what do I get? I get negative 5y squared multiplied by 3y. And then I got negative 5y squared multiplied by negative y squared. And do you see why it was necessary to understand the laws of exponents? Because now we have to multiply. You see, it comes right back to what we did last time. Negative 5y squared times 3y is?
Negative 15y cubed.
Perfect. And then negative 5y squared times negative y squared is?
5y to the 4th power.
Positive 5y to the 4th power. And that's it. Done. Done. So with multiplying, we distribute the terms, and we have to remember the laws of exponents that when we multiply same bases, we add the exponents. So that's going to come back again and again. Okay, I'll give you another example, and then we can move on to the second case. Actually, I'll give you two more. So if I have 2a squared b, for example, and I multiply this by 4a squared minus 3ab plus 2b squared, what's the result? This is a monomial again, right? A monomial. And I'm going to distribute to everything inside. So this becomes 2a squared b multiplied by 4a squared minus 2a squared b multiplied by 3ab plus 2a squared b multiplied by 2b squared. And then when I take each of these terms, 2 times 4 is 8. A squared times a squared is 8 to the 4th, b. Minus 2 times 3 is negative 6. A squared times a is a cubed. B times b is b squared. Plus 2 times 2 is 4. A squared times nothing is just a squared. B times b squared is b cubed. And that is the product. Okay, so multiplying is good, right? Nothing too crazy going on. Okay, good. I'll give you one more of these. I got something like this: 2x squared minus x square bracket x minus 3 multiplied by 2x minus 1 square bracket. Okay, so then you might be asking, what in the world is that square bracket doing? Well, that square bracket is just highlighting the fact that everything inside here is together, lumped together. And then within this group here, I also have another set of parentheses. So you can treat this as another set of parentheses. It's just that I'm just trying to highlight the difference between these and these. So to take care of this, you always have to start from the inside out. So take care of the inside parentheses first. And then I get what? I get 2x squared minus x. This is still out here, x. This will be now what? 6x plus 3. You see that? So I took care of the inside. And now I have to combine like terms. And so then I get 2x squared minus x, parentheses. I get negative 5x plus 3. And then what happens? Distribute that negative x that's on the outside. And I get 2x squared plus 5x squared minus 3x. And that equals 7x squared minus 3x. Done. Okay. So we're good with that. Okay, so that's the first case. Now the second case, case number 2. Case number 2 is when we multiply binomials. Multiply 2 binomials. Again, the word bi here means 2. So we're dealing with just 2 binomials. So an example of this is when I have 3x minus 2y, parentheses, 2x plus y. Does anybody know how to multiply this?
Yes, I know.
How?
So you multiply 3x to like 3x multiplied by 2x plus 3x multiplied by y.
Mm-hmm.
And the next is going to be plus minus 2y multiplied by 2x plus minus 2y multiplied by y.
Very good. And do you know what that method is called?
Multiplication method? I don't know.
Yeah, so there's an acronym. Of course, we always write acronyms, and that's right. Jerry and Adriana. FOIL. It's the FOIL method. Why is it called the FOIL method? Because exactly what you just explained in words. You said take the first terms, then take the outer terms, then take the inner terms, and then take the last terms. That's what the FOIL is for. First, outer, inner, last. So the first terms are going to be the first 2 terms here. These are the first, right? So I'm just going to write it like this, f. What is f? 3x multiplied by 2x, which equals 6x squared. Then the next one are going to be the outer, right? So the outer are going to be these here. This is my outer. So my outer terms are going to be 3x multiplied by y, which equals 3xy. Then what are going to be the inner ones? They're going to be the ones that are going to be right inside, in between the 2 parentheses. So it's going to be negative 2y multiplied by 2x. This is negative 4xy. Then the last are going to be these. And so these last 2 terms are going to be negative 2y multiplied by y, which equals negative 2y squared. So that's what we did. We FOILed. And so then this equals what? 6x squared minus plus 3xy minus 4xy minus 2y squared. But what do you notice? You can combine the outer and inner terms, right? Because they're the same, like terms. They're combined like terms. Combine like terms. So this becomes what? This becomes 6x squared minus xy minus 2y squared. Boom. So that's the first, outer, inner, last, also known as the FOIL method. There's 2 other ways to explain multiplication by 2 binomials. You can also explain this using the distributive property. So you can think about taking this guy here and distributing to this and to this. And so then I'll just show you. So this is the FOIL method way. I'll show you maybe another 2 ways, just in case if the FOIL method maybe is too messy for some, which might be the case. 3x minus 2y, I'm just going to do the same exact thing, and I'll show you how you get the same exact product. So one thing you can deal with is you can say that this guy here is 1 term, and I'm distributing it to each term inside here. So this is the distributive property. So So then I can say this. I can say that this is 3x minus 2y multiplied by what? 2x. Then I'm adding this by what? 3x minus 2y multiplied by y. And then what am I going to do with that 2x on the outside of the parentheses? I'm going to distribute that. And this equals 6x squared minus 4xy plus 3xy minus 2y squared. And if you notice, we get the same terms, same exact terms. And we get 6x squared minus xy minus 2y squared. The reason why it's noteworthy to even discuss this distributive property, even though everyone is much more used to the FOIL method, I'm pretty sure, it's just that the FOIL method only works. So let me just say, this FOIL method only works though. This only works for two binomials. That's it. Now the question is, what happens when we don't have binomials, when we have trinomials, or when we have bigger number of terms? How are we going to multiply them? Well, we're going to multiply them using this method, the distributive method, not the FOIL method. The FOIL method just sounds nice, and it only works for binomials. So that's why it's important to know the distributive property. And there's one more that people tend to like with the foiling. Instead of foiling, it's called like I think it's called the box method. So like, for example, if I multiply the same two, right? The same two binomials, I can do like a box and divide it into 4s. And then I can just say, this is each row will be the terms from one of the binomials, and each column will be the terms of the other binomial. And then you can treat this like a multiplication table. So this is 3x times 2x, which is 6x squared, and then you get 3xy, and then you get minus 4xy, and then you get minus 2y squared. So you see how we get the same exact terms again? It's just that visually sometimes it may help some people see this in this light. And then you start to see that these terms here in the diagonals, they're the same like terms, and you can combine them, and you get exactly the same thing. 6x squared minus 4xy plus 3xy minus 2y squared, 6x squared minus xy minus 2y squared. Yeah, it looks very similar to the Punnett square, Tyler. It is. It's very similar. I think the Punnett square, it calculates, deals with like the genes, right? The genes and how you pair the different genes, recessive with dominant. It's very similar. It looks like one. But the idea is that you can interpret multiplication of two binomials in different ways, but they give you the same answer. Okay. Okay, so then that's the two cases for multiplication. And there's one more, and then this is the most general way. This is the most general form. Case 3 is this is just multiplying multiplying polynomials in general. So then what happens is, what happens when I multiply, as an example, something like this, a plus 3b, and I have 2a squared minus 3ab minus 4b squared. Now that I have this, how do I multiply these two polynomials where only one of them is a binomial, the other one is a trinomial because of the 3 terms. So I can't FOIL anymore because foiling only works if you have two binomials. So what do I do instead? So remember what I said about the distributive property. We can just apply the distributive property. And the way I'm going to apply it is the following. I'm going to take this term here, and I'm going to distribute it to every term in the other polynomial. So I'm going to have a multiplied by 2a squared. I'm going to have minus 3ab multiplied by a. I'm going to have minus 4b squared multiplied by a. And then I'm going to take the next term and distribute that. Right? I think someone's alarm is going off. And then you got what? 3b multiplied by 2a squared minus 3ab multiplied by 3b minus 4b squared multiplied by 3b. Is somebody's alarm going off? Or am I just hearing things? Okay. Yeah. So do you guys see that? Do you guys see how I'm multiplying everything from these two terms here? I'm multiplying every term on the other one, and I'm multiplying this second term here to every term in the second polynomial. And then I have to be very careful and make sure that I multiply everything accordingly. So if I multiply a with 2a squared, I get 2a cubed. If I multiply a with negative 3ab, what do I get? Minus 3a squared b. And then 4b squared a, I get minus 4a squared b. 4ab squared. And so on and so forth. So on and so forth. I got this 3b times 2a squared, which becomes 6a squared b. And I got the minus 3ab times 3b, which is minus 9ab squared. And lastly, I got minus 4b squared times 3b, which will give me minus 12b cubed. Okay. And then I have to combine like terms. What are the like terms? Well, I got 3a squared here, and I got another 6a squared b here. And then I have to combine the 9ab squared with the minus 4ab squared. So when I combine those two pairs, I get 2a cubed plus 3a squared b minus 13ab squared minus 12b cubed. Right? Any questions about multiplying polynomials in a more general sense? No questions? Everything's clear?
Yes, Professor.
Everything's clear? Okay, good. All right. So multiplying, adding, subtracting, all good. I'm glad. Okay, so then I'm gonna do special products. So there are certain multiplications between binomials that are special, quote unquote. So one of those special products are called the product of sum and differences. Sum and difference of two terms. So that's when you have something like this. A plus B times A minus B. So this is a product of a sum and difference of two terms. So when I multiply this, right, what do I normally have to do? FOIL. So I do a times a is what? A squared. A times negative b is what? Negative ab. B times a is what? Positive ab. B times negative b is what? Negative b squared. Now, what do we notice about the negative ab and the positive ab? They cancel. And so what I get is a squared minus b squared. And that is a special product. And when we talk about factoring, this is also known as the difference of two different squares, two perfect squares. So this is gonna come back. This is gonna come back to us. So just a little example, right? So when I have something like this, 2x minus 1 multiplied by 2x plus 1, sure, I can FOIL things out, right? I can FOIL it out and then do what I have to do. But if I notice that this is a product of sum and difference of two terms, I don't have to go FOIL anymore. I know exactly the result. I know that the result will be whatever the first term is, right? This is going to be my a value. This is going to be my b value. This is my a value. This is going to be my b value. Whatever the first term is, I have to have an a, square that, and then b, square that, and subtract. So my a value would be what? 2x, but I'm going to square it. My b value would be what? 1, but I'm going to square that. And I get 4x squared minus 1. Again, this only works for this special kind of product. That's why we mentioned this to be a special product. Does that make sense? So that's one of them. That's one of the special products. The other one is called the square of a binomial. So the square of a binomial is this, a plus b squared, for example. So if I have a plus b and I square it, what's the result? Does anybody know?
Is it a squared plus b squared plus 2ab?
Very good. Very good. I thought you were going to say what everyone else would say, a squared plus b squared. So let me just say one thing before we continue. This is not a squared plus b squared. It is not. A lot of people make the same mistake every time. Every time we talk about this, they think it's a squared plus b squared because you distribute the two. No, you don't. You don't distribute the two. A plus b squared means what? A plus b multiplied by a plus b. So you have to be careful. And when you FOIL this, what do you get? When you FOIL this, you get a squared plus ab plus ab plus b squared. And so you're correct. When you combine the like terms, you have a squared plus 2ab plus b squared, or the way you said it, a squared plus b squared plus 2ab. But normally we put the squares on the ends and put the thing in the middle. So a plus b squared is always a squared plus 2ab plus b squared. So then if that's the case, then look what I can do every time now. So if I have something like 3a plus 2, if I square this, right? Of course, I can go 3a plus 2 times 3a plus 2 and FOIL things out. But because this is the square of a binomial, this is a binomial and I'm squaring it, I already know how it's going to end. I already know the result. The result is what? The result is the first term squared, right? This a here represents the first term. Square it. Then what do? I add by 2 times the first term times the second term. And then the last term, I square it. Do you see how I immediately get the result without having to FOIL things out anymore? because it's a special product. And this becomes what now? 9a squared plus 2 times 3 times 2 is 12a plus 4.
Wait, Professor, can you repeat that again? A little slower.
Yeah, repeat what exactly? Everything?
Yeah, this example that you just did.
Okay. So I'm only introducing two special products, okay? Normally, we just multiply things out the way we've done so far. It's just that when you have this particular kind of scenario where we have a square of a binomial, I already know based upon this result, I already know that the square of a binomial will produce something of this form. So here you have a plus b. When you square it, the result is a squared plus 2ab plus b squared. Now I'm giving you a specific example, 3a plus 2, and I'm squaring it. So if you notice, this is exactly the same, right? It's the square of a binomial. What I'm saying is you could do the steps of doing this, 3a plus 2, multiply by 3a plus 2, and you can go and do the steps. You can do it, right? You can do the foiling method. You still get the same answer. What I'm telling you is that you don't have to anymore because this example is exactly an example of the square of a binomial, which I already know what the result is. This is the result. So you can go through the traditional way of multiplying things out using the FOIL method, or you can recognize, hey, look, this is exactly this result. So that means I have to take the first term. This is my first term, right? I square it. Take the first term here, square it. Then I'm going to add by what? Twice the what? The product of the first and the second term. What's the product of the 3a and the 2? 3a and the 2. And then I'm going to add by what? The last term squared. Last term, right? What's the last term here? 2. Square that. And all I have to do now is do this individually and put them together. 3a squared is 9a squared. 2 times 3 times a, 2 times 3a times 2 is 2 times 3 is 6 times 2 is 12, 12a. And then 2 squared is 4.
Oh, okay. That makes sense.
Yeah.
Yeah.
So the moment you see it like this, the moment you see anything squared, I already know, or I should already know the result. That's all. And
Okay.
I'll give you one more of these. So there's actually two versions of this. So I'm just calling this version 1, right? Version number 1. And this is version number 2. Version number 2 is when you have a minus b squared, when you have a subtraction. When you have a subtraction, let's just go through the steps real quick, and then you'll see what happens. When I expand everything, right? When I FOIL, a times a, I get a squared again. A times negative b, I get negative ab. Negative b times a is negative ab again. And negative b times negative b is positive b squared. So I have a combined like terms, and I get what? I get a squared minus 2ab plus b squared. That's equal to what? A minus b parentheses squared. So this is the second version. So as an example, what if I get 5x minus 3 parentheses squared? Do you see now what I'm going to look at? This guy here looks like what? This thing here. I already know what this is going to be. It's going to be this. So just put it in that form now. I'm going to have something, square it. I'm going to have minus 2 times something plus something squared. But what are those somethings? So the 5x here is going to be the a. So this is going to be my a. This is going to be my a. So I'm going to have what? 5x, 5x. Then what's going to be my b's? This is going to be my b, right? This is going to be my b. This is going to be my b. So what's my b? My b here is going to be 3. Then my b here is going to be 3. So then when I do everything, I have what? 25x squared minus 2 times 5 is 10 times 3 is 30. So it's 30x plus 3 squared, which is plus 9. And that's my result. Again, you can go and do the foiling method if you want. That's fine. It's just that if it's in this form, you don't have to because you already know what the form would look like. That's all.
We only do it if it's in that form, right?
Yes.
The A. Okay.
Only.
Okay.
That's right. Any other form, any other multiplication of polynomials, you do exactly what we've been doing before, which is the distributive property. That's how we're going to do it. But these are special ones. So because they're special ones, we have a very special form for them. We have the result already. We just have to apply it. And again, this will come back to us when we factor, because whenever we take the square of a binomial, what we produce, if you notice, you produce what? A trinomial. And in particular, we go in particular, this example is what's called a perfect square trinomial. And Emil wants another one. Okay, I can do millions of these if you want. Let's say I have something like this: 7x minus 4y, for example. Okay, and I want to square this, right? What I'm saying is, guys, you can do this, right? You can do the 7x minus 4y, multiply by 7x minus 4y, and then go crazy with this, right? Go crazy with the multiplication. What I'm telling you is you don't have to anymore. Why not? Why not? Because it's this form. It's a minus b squared. A minus b squared. That's it. So I'm going to call this my a. I'm going to call this my b value. And what's the result of a minus b squared? It's a squared minus 2 times a times b plus b squared. This is going to be my a. This is going to be my a. This is going to be my b. This is going to be my b. So all you have to do now is rearrange it and replace wherever you see a. Instead of writing a, you write 7x. 7x. Instead of writing b, you write what? 4y. 4y. And then you just apply the operation. 7x squared is what? 49x squared. 2 times 7 is 14. 14 times 4 is minus 56, right? xy. And then 4y squared becomes what? Plus 16y squared, right? And that's it. That's it. If you don't do this, if you don't use this form, it's okay. You can still get the right answer. It's just that you don't have to spend that time anymore for this kind of example because of the form that it has. It's a special form. And that's all I wanted to really highlight. Okay. So we have these two different products. One of them is the difference of the product of the sum and difference of two terms. And the second one is the square of a binomial. Okay. So that's good. So far we've added polynomials, we've subtracted polynomials, and we've multiplied polynomials. So what's left? Well, obviously, we need to divide. So we have to divide polynomials, guys. And we're going to do so by long division. Now, for the sake of understanding what we're going to have to do, I'm going to take a trip back to middle school for some of you, or elementary school, or whenever it was that you learned how to divide by long division. So remember when we have something like this, 17 over 3, for example, how do we divide this? Like 17 over 3 is the same thing as saying what? 17 divided by 3? Now, how do we divide? Don't we put the 3 outside of the division symbol? And we put 17 on top, don't we? I mean, inside. And then what's the question? Does anybody know how we do this? I know it's very elementary, but how do we approach long division? Does anybody know the next step? Yeah, exactly. That's right, Adriana. How many times does 3 go into 17 without going over? So 3 goes into 17 how many times? 5. So what do? We put the 5 on top, right? And then what do we do after that? After we said it's 5, what do we do?
So you multiply 3 by 5.
And you
you
get?
15.
And then what do you do with the 15?
You subtract.
Subtract from
You
the
put
17.
15 underneath, right? And
Right.
then you subtract, right? And then what do you say? 17 minus 5, 15 is?
You get 2 remainder.
Right, you get remainder of 2, correct? So now everyone's looking at me like, what's going on? Right, you get 5 point, yeah, you get a repeated decimal. But we're doing the middle school version, or like the elementary school version. We're not doing the whole point, the decimal thing. We're just considering the remainder. So then let's put some terminology to this, right? So 2 represents what? 2 represents the remainder. 3 represents what? The divisor. 17 represents what? The dividend. And what does 5 represent? It represents the quotient. Remember, these are all terms that we discussed. I mean, that you may have seen before. So 3 is my divisor. 17 is the dividend, is the number that's being divided. Divisor is the number that's doing the dividing. 2 here represents the remainder that's left. And 5 is the quotient, the result of the division. So then you're like, okay, I get that. So what is 17 over 3? Is really what? 5. Well, actually, let me rewrite this. How can I rewrite 17? Let's rewrite 17. How can I rewrite 17? Can't I rewrite 17 like the following? 3 multiplied by 5, that's 15. And then I add 2. Isn't that 17? Isn't this true? That's another way to unpack what division is. Division is really just a multiplication problem. Division is really asking you, what is the number that when I multiply by a divisor gives me the dividend? That's really what division is asking. So I'm saying 17 can be rewritten as multiply 3 and 5 together and then add the 2 after. That's 17. And then you're like, okay, I get that. So why do I care about that? Well, if I divide by 3 everywhere, what happens? I get 17 over 3 equals what? 5 plus 2/3. So 17 over 3, and remember how you guys would normally write this as a mixed numeral? You would write it as 5 2/3. So that's the mixed numeral for 17 over 3. So then you're like, okay, I get that. That makes sense. But what am I really trying to get at? What I'm trying to get at is, what is 17 again? 17 is considered the what? The dividend. What does the 3 represent? Divisor. What does the 5 represent? The quotient. What does the 2 represent? The remainder. And what does the 3 represent? The divisor. This, you can consider this as something called the division algorithm. And this division algorithm is not just applicable to numbers. This algorithm is also applicable to polynomials. Nothing stops us from applying this algorithm to polynomials as well. So that's what we're going to do, guys. We're going to apply this to division of polynomials. But before we do that, we're going to do something a lot simpler. For example, right? So if I have a polynomial, 3a squared plus 2a, and I divide it by a, for example. This is a very simple kind of division. Because I can divide this by doing what? I can say 3a squared divided by a plus 2a divided by a. The a's here cancel, the a's here cancel here, and what's left? 3a plus 2. Now this is my quotient, and this is my divisor, and this is up here my dividend. And actually, I have no remainder here. There is no remainder. It's not the plus 2. The plus 2 is not the remainder. Because now we're dealing with polynomials. So we have to change our way of interpreting things now. Because now we're in polynomial world. We're not just in number world. So if I have something like this, for example, x to the 6th minus 3x to the 4th minus x squared, and I divide this by x squared, what I could do is separate everything. And I get x to the 6th divided by x squared minus 3x to the 4th over x squared minus x squared over x squared. X to the 6th divided by x squared, what do you do when you have the same bases? You subtract the exponents. So you get x to the 4th minus x to the 4th divided by x squared. Again, you subtract the exponents, you get 3x squared. And then x squared divided by x squared is 1. Okay, so this division actually, these are examples of division where the divisor is a monomial. Remember how we talked about multiplication and how we have different cases where we multiply by the monomial and then we just distribute, and then we have binomials, and then we have trinomials or larger polynomials. Well, in this case, we're just dividing by a monomial, which is just one term. And when we do so, it's very simple. We just separate the fractions into separate fractions from the numerators, and we take each numerator and divide it by the monomial. That's like the simplest kind. That's the simplest kind. But the problem arises when we have something like this. So this is when the divisor is not a monomial. So when it's not a monomial, we have to use long division. So an example of that is this: 6x squared plus x minus 5, and I divide it by 3x plus 2. Do you see here, I can't separate the numerators individually with the denominator. I can't do that because it doesn't give me anything worthwhile. So what I have to notice now is that this is my divisor, and this is my dividend. So what I'm going to do now is apply the long division algorithm. Now, we have to be very careful with this. The way this goes is very similar to the way we did 17 over 3, right? We ask ourselves, how many times does 3 go into 17 without going over? And we said 5, and so on and so forth. We did 3 times 5, 15, subtract the 2, and then we say the remainder is 2. So then the question is, how do we apply that here? What is the analog version for polynomials? So the way we do this is simple, but it takes a little more steps, and it's a little bit more tedious. 3x, we have to look at 3x, and we have to look at 6x squared. And we ask ourselves, what multiplies to 3x to get me 6x squared? So does anybody know what multiplies to 3x that gives me 6x squared?
So is it 2x?
Correct. So 2x is what we're going to put right above. So then you know this, 3x times 6 times 2x is what? 6x squared? That's what we just said, right? We just said 3x times 2x is 6x squared. So remember how we do this step here? Just try to remember the steps. Remember once we figured out this number here, what do? We multiply the 3 and the 5. We multiply this number with the divisor. We're going to do the exact same thing. We're going to multiply 3x plus 2 by the number that the term we just found, which is what? We multiply, right? We get what? 6x squared plus 4x. Isn't that what we get? But then what are we going to do after this step? After we multiply these terms here, what are we going to do? Oh, sorry.
You subtract the.
Yes. Yes. We're going to subtract. And this is where you have to be very careful. We're subtracting not just the 6x squared. We're subtracting the entire polynomial. You have to be careful with this. And this is where everything we just talked about subtracting polynomials come into play. Because we're subtracting what? We're subtracting this entire polynomial with this polynomial. And remember, what do we do with that negative to that second polynomial? What do we have to do with this -1? We have to distribute. So then when we distribute this, we distribute the -1, right? When we distribute it, you get negative 6x squared. You get a negative 6x squared, and you get a negative 4x. Do you guys see that? And then when you subtract, what happens? 6x squared minus 6x squared goes where? It goes out of here. And then what do you have? X minus 4x, which is what? Negative 3x. And then what do? You bring down what's not used, -5. Does everybody see that those sequence of steps? If you understand those sequence of steps, all you have to do now is repeat them and repeat it until you get a remainder. Now the question becomes, what is 3x and -3x? What do I multiply to 3x to give me -3x?
Minus x.
-1. Correct? It's -1, not minus x. So now we do what? Now what do? We take -1 and multiply it to this entire thing. So what is 3x plus 2 multiplied by -1? -3x minus 2, isn't it? So that's what we're going to do here. -3x minus 2. But be careful. What are we doing? We are subtracting it. So this thing is going to appear again and again. We're subtracting the product. And now what happens when we subtract it? You see why we're doing this? When you subtract it, what happens to the -3 on the bottom here? It becomes what? Plus 3x. And this becomes plus 2. And then why is this good though? Why does this work? What's -3x plus 3x? Cancels. This is what I want. And then what's -5 plus 2? -3. And we're done with the division. This is my remainder. Why is it? Because I can't multiply anything to 3x that results in a polynomial that gives me -3. There is no polynomial that when I multiply 3x gives me -3. So I can't do this step any further. So it's -3. And this thing above here, 2x minus 1 represents what? The quotient. And this here represents what? The divisor. So then to put this all into in its proper context, 6x squared plus x minus 5. When I divide this by 3x plus 2, what's the result? Remember the division algorithm? What is the division algorithm? The dividend over the divisor will result in what? The quotient plus the remainder over the divisor. What was the quotient here? The quotient was 2x minus 1. That's my quotient. What's the remainder? The remainder was minus 3. And what's my divisor? 3x plus 2. And so this is the final answer. And then you can also write this, because this minus here, there's this minus here on the numerator. You can also write this on the side of the fraction. So this is also equivalent and probably preferable over the previous one. Okay, guys, so that step, those steps in between, those steps here, you have to be very careful. You have to be. So that every single time that you go through the steps, the first terms here, they cancel. Those two terms here that at first, they cancel, and then we get this. And then the next time you do it, these terms cancel, and then you get the next thing. So that's how you know what you're doing is working. If things cancel out. If they don't cancel out, something's happening. You didn't either you didn't distribute the -1 correctly, or you did not multiply did not find the correct number that multiplies to the divisor to get rid of it. Alrighty.